Okay, so good, great, we're working. So hey guys, my name is Ryan Hunter. I work for Dropbox. I've been there for 3 years, and before I start my talk, I just want to say thanks to everyone involved in Pycon for making this happen. It's like one of the most amazing things I've ever seen before. I've never been to any Pycon or any programming conference before, so it's great to talk to a lot of people, see faces in front of emails. And I especially want to thank Jesse, Van, and Eva for putting this all together. If you guys want to, put a round of applause for them. It's truly amazing. So what I want to talk about today is basically how Dropbox did it and how Python helped. But actually, helped is completely the wrong word. What I should say is how it would have been virtually possible to do Dropbox without Python. Or even how Python's at the absolute core of our business. Essentially, we're just like a product company. We write software, and everything we write is in Python. So Dropbox definitely wouldn't exist if it weren't for Python. So short little thing about me. My name is Ryan Hunter. I told you guys that already. I grew up in Miami, Florida. I graduated from MIT 2008, relatively recently. I've been programming for about 10 years. I started with Perl, and I've been programming Python for about 5, so 2.4 or 2.3. I was a third engineer at Dropbox, and I originally ported Dropbox to Linux, so I joined the team. Thank you. I joined the team and I was like, Arash, this thing's awesome, but it doesn't work on Linux. And then he's like, well, we're case insensitive on the back end. And I was like, that really sucks. So if any of you use Dropbox on Linux, try renaming something with the same file name but different case, see what happens. It's a nice hack. And so at current time, I'm the lead engineer on the Dropbox SM client. This is a single code base that works on Windows, Mac, and Linux. By the way, it's all in Python. So what is Dropbox? I'm just not going to assume everyone here knows what Dropbox is, so I'll explain what it is. Basically, Dropbox is the easiest way to keep all your files safe forever, share your files with other people, your friends, your family, people you work with, and to always have access to all your files wherever you are. These are kind of the key points that we think are important for Dropbox. So how does it work? So basically imagine you have a home computer and a work computer, and you install Dropbox on both these computers. It will create this Dropbox directory on your computer. And let's say you're at home and it's the morning before you go to work and you need to have a file on your work computer before you get there. So you just drop this file in the folder. Dropbox starts doing its thing, starts syncing, beeping, whatever. And then instantly, within seconds, you won't be able to see it, but that file will be on your work computer. And we take care of all the messy, corner cases around sync. It can get pretty nasty, but Dropbox just works. But there's more. You can access your files from the web, even as 1992. You can access your files from the iPhone, Android, BlackBerry, and the toaster one day. That's what we want, and that's where we really see Dropbox going. Glad you got that. And so this whole time, we've been going through crazy, crazy growth, way more than any of us ever really thought. We're the fastest growing commercial app since Skype. Believe this or not, more files are saved in Dropbox per day than people are tweeting. That's 1 million files every 15 minutes. It's ridiculous. And people really like this thing. We hear thousands of emails every day. They're just like, we can't live without this. How are we living without this? And another nice point is that we've done no advertising, no Super Bowl commercials that insult people. Just all word of mouth, just spreading through Facebook, Twitter, and if I ever were going to be a part of a company, it would be something like this, because I think that just is a testament to how good of a product Dropbox is. It appeals to a real need. that people have today. So I'm going to give you guys kind of like the Aaron Sorkin style background to Dropbox, how it all got started, why it got started, and so it starts with this guy. His name is Drew Howson. He's an MIT 2005 graduate. He's been hacking since he was 12. He's ridiculously smart, one of the smartest people I know. And he's been involved in startups since he was 16. I think, I won't talk him up too much, but I think he told me his first job was 16. When he was 16, he was doing like Linux, IRQ handler, something ridiculous like that. And he had founded a SAT prep company before this, trying to get his feet wet with founding companies. So it's summer 2006, and he was a scrappy new graduate from MIT, and he's just basically not different from anyone else. He had a coding job. He was basically coding all day, going home, coding all night. And this summer, a lot of his friends were doing Y Combinator. So Y Combinator is this incubator company that basically gives startups money, about $15K per summer, to like build a product, and then at the end of the summer, demo it to a bunch of investors. So he was doing Y Combinator that summer, but all his friends were. And basically, at the end of the summer, all of his friends moved out to San Francisco. So he was just like, well, what do I do now? Because the best time of my life was this summer, and all my friends are gone. So he really wanted to start a company. He really wanted to be a part of it and do something great and recognized. I think things were happening, like Justin.tv was on the Today Show, ridiculous stuff. So he was really ready to make an impact. But he didn't know what he was going to build. And basically, Y Combinator's motto is make something people want. So Dropbox came to him one day when he was taking the bus from Boston to New York. If you guys are from Boston or have been there, there's this bus called the Fungwall bus. This pays $10, and for $10, one-way ride to New York from Boston. So he has his computer. He basically like set up all his stuff, and he gets on the bus, and then he opens up his laptop, and then he's like, crap, I don't have any of my files. I don't have my... So he stored all his stuff on his USB drive. So he really, at that point in time, he was like, why is this happening to me? This should never happen to anybody. And then like the light bulb went off in his head. He's like, this is a startup. And he realized this was a startup because like the competition was horrible. Everything else was either too slow, too complicated, or just broken. And he really thought it shouldn't be this way. And Dropbox came to him. So basically, he started working December 2006. And 4 months later, he had a Windows-only prototype in 2007. And what he realized is that he did this whole prototype in Python. And I can't remember how many lines of code it was, maybe something like 3,000. And he realized that this stuff is really hard. For the vision he saw, something being cross-platform efficient, backed by the cloud, you couldn't really do that in a weekend. It's really impossible. And quick note, yeah, he got 80% of the way there using Python, which is pretty important. So at that point, was the world ready for Dropbox? Should he put all his time and energy into making this thing if it wasn't even going to be worth anything, if no one cared? Was there even a market? Would people pay for this? This didn't really exist out there in the commercial world. And should he release it early, or should he just like wait until the product is usable, which could be how many years? I don't know. So he decided to basically make a screencast video, which is, looking back on our history, has been super important for us. So if you guys know what Hacker News is, it's basically this news website, kind of like Dig or Reddit, but it's just basically stories about things you care about, like programming, how to start a startup, psychology's in there too. So the Y Combinator community kind of like circled around Hacker News and used it a lot for the main news source. So he's like, let me just appeal to like everyone I know. And he put this video up displaying Dropbox on a Windows PC. And the response was like incredible. He received like thousands and thousands of replies on this email list. They're like, this is awesome, I really want to use this. And it hit him like, this is a big idea, like this actually is going to go somewhere. And kind of he decided like, I'm going to start a company now. Unfortunately, he didn't have any money and he didn't have anyone else to found the company with. Paul Graham was kind of like very, very forceful, saying like, startups with one founder almost never make it. So he really needed a co-founder. And this is where Arash comes in. So Arash is actually a friend of mine from MIT at the time. And at this point in time, it's like spring 2007. Drew had been going through co-founder to co-founder to co-founder. And none of them like really appealed to him. None of them like really resonated with what he was saying. And then he met Arash. On the parallel side, Arash is my age, my year, and basically his friend Kyle, who left school to work at Justin TV, had left and was like in San Francisco and like building a startup, and it was really awesome. And Arash was like, I want to be a part of that. I want to do that too. So basically, Kyle hooked him up with Drew, and they met, and it just worked. All right. There was a lot of synergy between them. And of course, Arash was incredibly smart. He's also one of the smartest people I know. He was really well known around MIT for being like a really great hacker, just because he's done so many amazing things. So naturally, now they had a co-founder, they applied to Y Combinator for summer '07. And this link is kind of the application. So if you guys want, you can just go there now and check out like, check out kind of the more fleshed out details that Drew was doing, or thinking at the time. So Y Combinator was great because they met tons of investors, tons of other technology leaders, other founders who just like shared their experience and like the pitfalls they went through and just like how this thing works, like how do you start a startup. Their pitch at the time wasn't so great. So Drew told me that they would go to these VCs in Boston, and they'd be like, the VCs would be like, why do we need another cloud storage company? There's about like 50 of them out there, and none of them are great. Like, what are you guys doing different? And Drew was like, well, he couldn't really say what we were doing differently. He didn't have a way to pitch the product. But he'd always say, do you use any of these products? Like, there's actually an opportunity here to be something that's appealing to most people. And so the final thing that Y Combinator really helped with is that they introduced us to Sequoia. So Sequoia is an investment firm in California, in the Bay Area especially, and they've invested in companies like Google, YouTube, PayPal. So we met up with them, or we got an intro to them, and basically they were super excited about Dropbox, and they were like on board immediately, which is really important for us. So I kind of wanted to go over the early team, because in addition to being able to iterate fast and like being very anal about like code quality and like quality of the product, their early people made a big difference. It should be clear from looking at this that like we were basically all friends of Arash, and we were all like pretty young at the time, recently graduated. None of us had a real job before, so this is all like kind of our first industry experience. But we were the smartest, hungriest, passionate hackers we knew. If it was clear here, like we all kind of knew each other. I don't think any of us were like close friends. We all had like different networks out there, but we all knew of each other at least. So the good point here is that like being super passionate, being super driven and smart, but yet not having a lot of experience is something that really resonates well with this whole like iterative development methodology that Python allows. No other language really allows you to kind of just like put something out there and iterate fast on your design. Python's one of a kind on that. So this is a picture of us, the early team. It's kind of ridiculous. This is when we hit 1 million users in April 2009. You can see the team's small, very scrappy. So I wanted to go over like some of the high-level achievements like that this team did back then, or in 2009, 2008. So probably one of the hardest things we've done, and maybe this is not even the hardest thing anymore, but to me it certainly is that we had to reverse engineer the Finder. Basically, we open a mock port into Finder, inject code, and then basically interpose ourselves between the native functions, the native drawing functions that Finder does. And this way, we get it to show either the syncing icon or up-to-date icon. This is like ridiculous for anybody to do. I don't think any other corporate business would do something like this. It's really risky. But at the time, we just wanted it to work, and we wanted to show off that we can get this stuff to work. We built this massive HTTP notification infrastructure to avoid polling on the client side. So early versions of Dropbox would just hit the server like every 30 seconds to say, like, is there new changes? Are there new changes? Are there new changes? And that just wouldn't scale. Like, there's no way on earth. If you have like 30 million clients you distribute all over the world, that factor is just, the factor of load is just too high. So yeah, we want to say thanks to Twisted Guys for helping us get that out there. Awesome. Another accomplishment, this is kind of more hard to qualify, but we were able to like build this one code base in Python that ran on Windows, Mac, and Linux. At the time, I didn't really realize how rare it was, but basically very few other people out there distribute Python apps at this scale. So I mentioned something like 20 million, in the tens of millions of hosts out there. So we want to say a big thanks to these projects, because if without these, like, it wouldn't exist either. It would be really difficult for us. So PyObjective-C, WXPython, CTypes, Py2XE, Py2App, on Py132. Thanks, you guys. Or thanks. So the major early accomplishments, keep going. We had this horizontally scalable sync backend on MySQL. Before, our backend was kind of, wasn't really horizontally scalable or parallel, so we got that working. We created this real-time analytics infrastructure, which is just a bunch of servers constantly churning on data. And another big one is that we added a couple of custom memory allocators to Python to decrease memory usage by 90%. When I say 90%, let's say you dropped like the Firefox source tree in Dropbox version 0.6. Your memory usage will just keep growing and growing and growing until you like add a memory error and like Linux would crash you. So this actually helped us get down, put an upper bound on that and get us like 100 megabytes. But I'm going to talk more about this later. So this part of the talk I want to talk about why Python, how Python. So we use Python everywhere. 99.9% of the code at Dropbox is in Python. We use it on the server backend, the desktop client, website controller, API backend, analytics. Unfortunately, not the Android or iPhone because memory constraints are really high there. But it's basically like the lingua franca of Dropbox. People talk to each other in Python, express ideas in Python. Just sort of dictionary at, just sort of sat at it, with this. And it works. It's just how we communicate all our complex ideas. So it should be obvious to us why Python's awesome. I've been talking about it for a while, but it's easy to learn, it's easy to read, easy to write, easy to modify. It's really helpful when a new person on the team has no programming experience with Python. They learn it in like a day. And just being easy to read, I can work on the client, I can work on the website, I can work on the server backend. It's self-documenting sometimes. It's easy to write, so you can code something in a day. Someone says, I don't think that's possible. You're like, I'll see you tomorrow. And it's easy to modify, so you don't have to recompile, just iterate fast. And it's dynamically typed duck type, which is amazing. A really nice thing that made my life easier is that it's really easy to dynamically instrument Python. I'm sure for reasons you guys all know. So in addition to the people, like I said, stability and quality was super key to the success of Dropbox. It's a really hard project. There's so many different orthogonal directions that you have to execute well on. Server side, client side, analytics, website, browser. It should just work. It doesn't matter. You could be running a case-sensitive file system. You could be running a versioning file system. You could be running like HFS, NTFS, anything. It should just work. It should work in all use cases. So iPhoto should be able to sync to Dropbox as well as like AIM chat logs or Firefox cache directory. It should just all work. It doesn't matter in what order they do file operations. And we should handle all error conditions. So one of the craziest things that I've seen is that, like, when you're just a random coder, you never have to deal with like error no, 81. Like, what is that? But like out there, when you have like hosting to tens of millions, you see like the most obscure errors you ever see. And this is kind of like how we just iterated fast and saying like, okay, great, like E not dir there, E ROFS there. And basically just tease out all these exceptions until we had it something really solid. So how do you ensure quality? They're kind of like two different schools of thought. Some people will say, take 3 to 5 years, design the perfect system. Then once you designed it like by this super overpaid architect, then you release it. Or you can just code something in a day, mostly works, and you just iterate on that. Python enables developers to take the second option. No other language does that, or very few languages do that. But this is an issue. Like, Python uses too much memory. It's too slow. It's impossible. It's not impossible. So server-side is not as big of a deal. That's why Python's really successful for server-side stuff like Django and Pylons. You can just throw money at the problem. If you need more memory or CPU, not a big deal. But unless you're willing to purchase new computers for your customers or your users, money won't help you on the client side. You can't make the one guy who's running PowerPC G3 to upgrade. It's impossible. And he will continue to use Dropbox. So there are a couple of tricks. I'm going to go over, basically, at this point, how we kind of overcome those two things. So this first thing is kind of a trick I use oftentimes. So when you're optimizing for CPU, you just want to focus on the inner loops. Like, everything else doesn't really matter because it's just run once. And most computers are reasonably fast to run things once fast. So here you can see there's basically two functions that do the same thing. The top one has an explicit for loop. This basically iterates with the Python VM with like maybe 5 or something bytecodes, and then calls update over and over again. That's great, except for bytecode dispatch is like really slow. When you've basically coded it up as like a composition of like iterators, a compose of iterators, and then just pass it to any to run, you get massive speed improvements. And that's mostly because the VM isn't responsible for doing the looping for you. So just less bytecodes to execute. So yeah, 44% of overhead when looping Python versus C. This is a neat trick I learned just after understanding how the whole stack worked. And I was like, well, we should just do things that way. So the gist of it is that optimizing CPU is super easy. There exists like tons of tools for profiling CPU usage. And if you don't have the tools, it's relatively straightforward to make the tools. Also, CPU optimization is really self-contained in a small part of the code. Optimizing memory usage is hard. Very, very few tools are available to allow you to understand how your program is using memory from a high level for both Python and C. And there's so many reasons that memory usage like skyrockets in like modern apps. It's because of memory leaks or memory fragmentation or just plain inefficient use of memory. So this is kind of our biggest problem early on, and this is actually my problem that I had to solve. So I spent a lot of time thinking about this stuff. So I was like, okay, I'm just going to go through this one by one. The first thing I wanted to figure out was, are we just using memory inefficiently? The basic process is like, read the entire code base, figure out what data structures are just growing unbounded, find like really bad inefficiencies, and there were a lot. And then I fixed them. Months later, because this is not an easy process, everything's still bad. I really didn't fix anything. So then I just measured the memory usage of all our dependencies, all the libraries we used. We used an ORM at the time, so that was actually pretty bad for us. Imagine you're syncing 50K files and then you spin up 50K ORM objects. It's not a good sight. Months later, overall memory usage was still pretty bad. So I reasoned something else must be wrong here. I've done as much as I can do. So the next big theory I had is like, it has to be a memory leak. There has to be a memory leak somewhere, either in Python, some module use, either a weird Python memory leak. And so this is basically a graph over time of memory usage. The graph goes up when you do a malloc. The graph goes down when you do a free. And what I noticed is like at the end, you basically see that the memory goes back down to a reasonable level. So there definitely wasn't any memory leaks. But RSS was still like 800 in the gigabyte range. Like, what was going on here? So the final thing is I reasoned it had to be, or just by process of elimination, it had to be memory fragmentation. Most allocations are done in the main heap, so when you call malloc, everything goes in this one long stretch of memory. And you know, when an app is using malloc doesn't know how you're going to use your memory. So you're mixing small allocations with large allocations. You're mixing short-lived allocations with long-lived allocations. And CPython doesn't have a compacting GC, so what you end up with at the end of the day is like a memory map that looks like this. Imagine if you moved all the blue to the left and all the red to the right, and then just cut off the red. Then you have a lot of free space. But unfortunately, the operating system just can't free pages in the middle of them. It's either the whole 4K page or none of it at all. 2 minutes. So there's no general solution to this problem. General purpose memory allocation is hard. So basically, the site is like I have to write a custom allocator. There was one object that we thrashed the heap with a lot, and that was basically the object that contained the file metadata. This is the object that will grow rapidly when you're syncing tons of files. And I basically thought, like, hey, what if we just put this object somewhere else? So when I was digging through this stuff, I found that CPython actually allows you to control how extension types are allocated. So there's these nice two callbacks called tpalloc and tpfree. And you can just say, I want my type to call this allocator. So this is basically the design of my custom allocator. It's just n 4 megabyte regions that are called by mmap, or allocated using mmap. And they're just in different spaces of the address space of the process. And there's like a region header per region. There's like each buffer is fixed size. The important thing is that none of this is rocket science, right? It's like not really hard to design something like this. It's just C code. So what about internal fragmentation? This is where each region only has one buffer in it. You could potentially need a lot more wasted space, space to space where n times 4 megabytes, we're only using n times size of your struct. But the key assumption here is that this allocator is only for short-lived objects, and that was how I was using it. So it works. Eventually, all the memory gets returned again, and everything gets freed up. So the end result is now we use less. Now we don't use more than 100 megabytes, and we're working to bring that even lower. So there's more. Instead of having to write a custom type, it would be super great if I could just do. Python always supports slots, so it'd be super great if I could just do something like use region allocator, and then the heap type would just use that region allocator. So what I ended up doing is I hacked type new and inside type object.c, and I got this flexibility for any object I wanted at runtime, and that was really helpful to us. So the last thing is that PyPy makes all this null and void. If you use PyPy, you don't need to do any of this stuff. So a big thanks to the PyPy guys for making this happen. And someday we'll port over, not now, but we'll get there. So I'm running out of time, but really quickly, future of Dropbox. People often tell me, like, where's Dropbox going? It already works. Like, what else can we do with this thing? Like, what are you guys even doing anymore? You just sit back and do nothing? And that's not true. There's still a big problem with the way people use their data in this day and age. People are basically afraid to store data and store photos and store movies because they have no place to put it. Like you put it on your PC, but that PC dies 10 years later and you lose it all. And then also if you want to use a new app on the internet, it has new privacy policies, new management interfaces, passwords to remember, it's too manual. So Dropbox kind of solves this problem because there's only one management interface. It's just your folder. If you don't want pictures in the cloud, just delete that folder. That's it. So basically imagine a world where every app and every device is syncing with Dropbox. And so you drop a file on your phone, and then on all your PCs across the world just have the file instantly. And we really want to bridge the gap between a desktop and the web. There's really big opportunity there. So basically what Dropbox allows is, imagine your mom puts your baby pictures in your Dropbox folder today, and 20 years later, in 2034, you're on the beach with your kids, and you pull your iPhone, they're like, hey, what did you look like when you were a baby? And you pull your iPhone and you show them the same picture that your mom dropped in your Dropbox 20 years ago. Oh, that's the power of it, and it really can change the way people save their data and use their data. So that's it. Thanks guys for having me. Thanks for listening to me talk. Clap. So really quickly, if you love coding Python, we're hiring. So just talk to us in our booth. We're there and we love to talk. So thanks.